Dear learners, today I welcome you for exercise 1.3 part 2 of mathematics grade 9. In previous lesson we have solved first 4 questions of exercise 1.3. Question 1 we have solved, question 2, question 3 and question 4. In today's lesson we are going to solve question 5, question 6 and question number 7 and 8. So we are going to start from question number 5. Matrices are given A, B and C and we have to verify the following rules. So I'm going to solve few parts of these questions, and in this part number 1, 2 and 3 they are similar, so I am going to solve part number 3, that is B plus C is equal to C plus B, and the matrices are given, B and C matrices are given. So let's start. Question number 5. Question number 5, part number 3, that is B plus C is equal to C plus B. So first of all, we will write the matrices of B and C. So B is given, that is, let's see the entries. 1 minus 1 1, 2 minus 2 and 2, 1 minus 1 1, 2 minus 2 and 2, and in the next row the entries are 3 1 3, 3 1 3, and in the same way C matrix is also given, and the entries of this matrix C is minus 1 0 0, this is the first row, minus 1 0 0, and second row is given 0 minus 2, 0 minus 2 and 3, and in the third row the entries are 1 1 2, 1 1 2, and we have to verify this B plus C is equal to C plus B. So first of all we are going to solve this side, this is the left hand side, that is B plus C. So left hand side, that is B plus C, is equal to B matrix, that is 1 minus 1 1, then 2 minus 2 2, 3 1 3. It is going to add with the C matrix, that is minus 1 0 0, 0 minus 2 3, 1 1 2. So dear learners, in previous lesson we have discussed that how we can add two matrices or more than two matrices. So the order of B matrix is same as the order of C matrix. So we will add the two matrices. This entry is going to add with this one, that is minus 1. And minus 1 of this matrix is going to add with this 0. Minus 1 plus 0. This one is going to add with this entry of the other matrix. And in the same way you are going to add the next rows. 2 plus 0, minus 2, minus 2, 2 plus 3, and in the same way third row you have to add 3 plus 1, 1 plus 1 and 3 plus 2. So now you have to simplify that 1 minus 1 gives you 0, 2 plus 0 gives you 2 and 3 plus 1 gives you 4. Minus 1 plus 0 minus 1, and this minus 2, when we add minus 2 here it gives you minus 4. 1 plus 1 gives you 2, and in the same way you have to add these values and you will get 1 5 5. So this is the matrix which we achieved for left hand side by adding b plus c. So now we are going to solve the right hand side, that is c plus b, and if the result of the c plus b is similar to this one, then this is verified that left hand side is equal to right hand side. So first of all, in this right hand side we will write C matrix first. Now we are going to solve right hand side, that is C plus B. So C matrix is given, that is minus 1 0 0 and 0 minus 2 3, 0 minus 2 3, and then the entry of third row is 1 1 2, 1 1 2. You have to add here B matrix, and the entries of B matrix are given 1 minus 1 1, 1 minus 1 1, 2 minus 2 2, and third row is given 3 1 3, 3 1 3. You have to add these two matrices. If you add these two matrices, you will get minus 1 plus 1, 0 minus 1, 0 plus 1, and in next row 0 plus 2, minus 2 minus 2, and then 3 plus 2, and now we have to add third row 1 plus 3, 1 plus 1, 2 plus 3. And now if you simplify this, you will get minus 1 plus 1 0, 0 plus 2 gives you 2, and here it is will be 4, minus 1 minus 4, 1 plus 1 gives you 2. I am just simply adding these values. So if you see, these entries are the same as we have the entries for left hand side. So you can say that left hand side is equal to right hand side. So B plus C is equal to C plus B, hence it is verified. So in the same way, you have to solve the other parts of this question, question number 5. So if you see first part and the second part, it is similar to the third part. In this you have to add two matrices for the left hand side and then two matrices for the right hand side. If the result is same of left hand side and right hand side, then it is verified, otherwise it is not verified. So now I am going to solve one more part. If you see, the fourth part is similar to the 10th part, and even it is similar to this sixth part as well. So I am going to solve one of those. So I am going to solve 10th part. So that is 2a plus 2b is equal to 2 into a plus b. So let's move towards question 5, part number 10. Part number 10, that is 2a plus 2b is equal to 2 into a plus b. So always remember that first of all we have to solve the parenthesis. Within the bracket, whatever we have to solve that one. In this, when you are going to solve right hand side, first of all you have to add the two matrices. Whatever the result you will get, you have to multiply it with 2. So first of all we will solve left hand side and then right hand side. So left hand side is 2a plus b, 2a plus 2b, 2a plus 2b. So matrices are given. Let's see what is A matrix. 2a into A matrix. A matrix is 1 2 3. The first row is given, that is 1 2 3, 1 2 3, and second row is also given, that is 2 3 1, 2 3 1, and the last row, third row, is 1 minus 1 0. So we will multiply this 2 with A matrix and plus 2 into B matrix. B matrix is given, that is 1 minus 1 1, 2 minus 2 2, 3 1 3. So first of all, we will multiply 2 with these matrices and then we will add the entries of these two matrices. So when we multiply this 2 with this matrix, the entries will be 2 multiplied by 1, 2 multiplied by 2, 2 multiplied by 3. You can do it direct as well. So 2 into 2 with second row, I am multiplying this. 2 into 3, and then this 2 is going to multiply by this 1. It will be 2 into 1. And in the same way, you have to multiply this 2 with this third row. 2 into 1, 2 into minus 1, 2 into 0. And here I am going to solve it directly. If I multiply this 2 with the entries of this one, it will be 2 multiplied by 1, 2, 2 multiplied by minus 1, minus 2, 2 multiplied by 1, it will be 2. This 2 is going to multiply with this row. It will become 2 into 2, 4, minus 4 and 4. Now I multiply this 2 with this row. It will be 6 plus 2 and 6. So in this way you have to do this, and now we are going to add these two matrices. So before adding, I haven't written here the direct values, so let me simplify it first. 2 4 2 4 6 6 2 minus 2 and 12. So now you have to add these two matrices, 6 2 and 6. Now add these two matrices. 2 and 6. So if you add these two matrices, you will get 2 plus 2, 4. If I do it directly, it will add with this one. This 4 is going to add with this one. So you will get 4 minus 2 is equal to 2. This 6 is going to add with this 2. It will give you 8. This is the first row. And in the same way, you have to add the second row with these one. So 4 plus 4 gives you 8. This 6 is going to add with this minus 4 gives you 2. 2 plus 4 gives you 6. Now this 2 is going to add with this. It will give you 8. Minus 2 and this 2. And this minus 2. When we add these two values, you will get 0. And 12 plus 6 gives you 18. So we have solved left hand side, and these are the entries of the left hand side. Now we are moving towards the right hand side, that is 2 into a plus b. So first of all, we will solve the matrices a and b in right hand side, and then whatever the answer we will get, we will multiply it. 2 into a plus b. This is the right hand side, and so first of all we have to solve the parentheses. So a matrix is given, that is 1 2 3. First row is 1 2 3, and second row is 2 3 1, 2 3 1, then 1 minus 1 0, and we will add here b matrix, that is 1 minus 1 1, 2 minus 2 2, 3 1 3. So first of all you have to solve the parentheses. So when we add these two matrices, we will get 1 plus 1, 2 minus 1. I am adding this row with this one. So this one with this one, and 2 is going to add with this minus 1. And 3 is going to add with this one. 3 plus 1, 2 plus 2, 3 minus 2, and 1 plus 2. In the same way, you have to add the third row of two matrices. 1 plus 3, minus 1 plus 1, and 0 plus 3. So what you will get from here, it will be 2 1 4 4 1 3 4 0, and it will be 3. So now you have to multiply 2 with the entries of this matrix, and you will get here 2 multiplied by 2 gives you 4, This 2 is going to multiply with this one, it gives you 2. When this 2 is going to multiply with this 4, it gives you 8. And when this 2 is going to multiply with this, it gives you 8. 2 multiply 1 gives you 2. Then 6, 8, 0, and it is 6. Now if you see, either this is matching with the left hand side result. Yes, it is, I think. Yeah. So it will be, uh, let me see again. It is not matching here. We are getting 18. Let me see that either we have, yes, we have done mistake that it is 0. It is not 6. It was 0. When we multiply this 2 with this 0, we will not get here 12. It will be 0. So 0 plus 6 gives you 6. So it will not be 18. It will be 6. So now they both, though the both matrices of left hand side and right hand side are same, so we will say that left hand side is equal to right hand side, and hence it is verified. So in the same way you can solve the other parts as well of this question number 5. So I am going to solve one more part, that will be that fifth part is and seventh part and even ninth part. These three parts are similar, so I am going to solve this one. This that is seventh one. Here what you have to do, you have to first of all subtract C matrix from B, and then whatever the result you will get, you have to multiply it with A matrix, and then you have to solve right hand side, in which you have to subtract C matrix from A, and then whatever the result you will get, you will subtract it from B. So let's solve part number 7 of question number 5. Question number 5, part number 7, that is C minus B into A is equal to C minus A in minus B. C minus A minus B. Here we have to bracket. So we are going to solve left hand side first, in which we have to subtract C from B, and then we have to multiply the result with A matrix. So when we solve this, the matrix which is given for C is, that is written here, minus 1 0 0. First row is given minus 1 0 0. Then it is given 0 minus 2 3, 0 minus 2 3, and then 0 1 2. We have to subtract this from B matrix. Then B matrix is given, I think, 1 minus 1 1, 2 minus 2 2, and 3 1 3, I think so. Yes, 3 1 3, 3 1 3, and this is not 0, this is 1. So whatever the result we will get, we will multiply it with A matrix. So I'm not having this space here, that's why I'm writing A. It is also fine. You can do this as well. Later on you can substitute the values. So minus 1 minus this value. So minus 1 minus 1. This 0 is going to subtract from this 0. This minus and this minus will become plus 1. 0 minus 1, and then this 0 is going to subtract from this 2. 0 minus 2 minus 2 plus 2. Why it is plus? This minus and this minus is going to be the positive one. Then 3 minus 2, 1 minus 3, 1 minus 1, and 2 minus 3. So if we simplify this, we will get minus 2, minus 2, minus 2, 1, 0, 0, minus 1, 1, and minus 1. I have just subtract the values, and now we will multiply these values with A matrix. So A matrix values are given, that is 1, 2, 3, 1, 2, 3, and let me see again, 2, 3, 1, 2, 3, 1, 1 minus 1, 0. These are the entries of A matrix. So again check either the order, or you can say in when we have to multiply, we see that the first matrix having the same number of columns as the second as having the number of rows. So now we will multiply these two. So this minus 2 is going to multiply with this 1, minus 2 into 1, and this one is going to multiply with this 2. In this way we do multiplication, this row and this column, 1 multiplied by 2, it will be in this way. Then this minus 1 is going to multiply with this entry, and in the same way you have to multiply this complete row with this column. So it will be minus 2 into 2. This one is going to multiply with this one, 1 multiplied by 3. This minus 1 is going to multiply with this minus 1. So now again you have to multiply this complete row with this column. So minus 2 multiplied by 3, 1 multiplied by 1, and minus 1 with 0. Minus 1 with 0. So in the same way you have to multiply this second row with these columns. So minus 2 is going to multiply with this one, 0 is going to multiply with this 2, and this one is going to multiply with this one. Now this second row is going to multiply with the second column. Minus 2 multiplied by 2 plus 0 multiplied by 3 plus 1 multiplied by 1 minus 1, and then this row second one is going to multiply with the third column, that is minus 2 multiplied by 3 plus 0 multiplied by 1 plus 1 multiplied by 0, and now this third row we have to multiply with this one. So it will be minus 2 into 1 plus 0 multiplied by 2 plus minus 1 multiplied by 1. Then again we will multiply this with the second one. So it will be minus 2 into 2. Entries of this row is same as in the second row, only the difference is this was positive and this is negative. Plus 0 multiplied by 3 plus minus 1 multiplied by minus 1. Now you have to multiply the third row with third column. Minus 2 multiplied by 3 plus 0 multiplied by 1 plus minus 1 multiplied by 0. Now if you simplify this, it will be that minus 2 multiplied by 1 gives you minus 2, 2 plus multiplied by 1 plus 2, minus 1 multiplied by this one, it will be minus 1. In the same way you have to solve this one. Minus 2 multiplied by 2 minus 4, 1 multiplied by 3 plus 3, minus, and this minus will become positive, so it will be plus 1. Then multiply this, minus 2 multiplied by 3 minus 6, 1 into 1 it gives you plus 1. Then 0 is here, so whenever you multiply 0 with any number you get 0. So now solve this row, minus 2 plus 0, because 0 into 2 gives you 0, plus 1. Minus 4 plus 0 minus 1, and then minus 6 plus 0 plus 0. 0 into 1 and 0 into 1. Now solve the third row. Minus 2 into 1 gives you minus 2 plus 0 minus 1. Then multiply this. Minus 4 plus 0 and plus 1, because this minus and this minus will become positive. Minus 6 plus 0 and plus 0. So now you have to simplify further. Minus 2 and plus 2, it will be 0 and minus 1 will left. If you add these value, minus 4 plus 3, it will be minus 1, minus 1 plus 1 will be 0. From here you will get minus 5, minus 6, minus 6, minus 4 and minus 1 gives you minus 5, minus 4 plus 1 gives you minus 3, minus 2 plus 1 minus 1 and minus 3. I have just add these values. So this is the matrix which we got for left hand side. So now you have to solve C minus A, and the result is going to subtract from B matrix. So I hope so that will be done by you, and if it is same, then you can say that left hand side is equal to right hand side. So now we are moving towards next question, that is 6.1. In this A and B matrix are given, you have to find 3A minus 2B. It is very simple question. You have to simply multiply A matrix with 3 and B matrix with 2. So whatever the result will be, you have to subtract the both of the matrices. So I'm not solving first part, I have explained it to you, and I'm going to solve second part, in which transpose you have to take. So before multiplying with 2, you have to first of all take the transpose of A and transpose of B, then you have to multiply. So question 6, part number 2, we are going to solve. Question 6, part number 2, that is 2A transpose minus 3B transpose. A matrices are a matrix is given, that is 1 minus 2 3 4, 1 minus 2 3 4, and B matrix is also given, that is 0 7 minus 3 8. 0 7 minus 3 8. So before solving this, we have to take the transpose, or you can do this in the same way as well, that is 2 into 1 minus 2 3 4 and its transpose, and minus 3 into B transpose, that is minus 3 and its transpose. I have just substitute the values, or you can say substitute the matrices in this one. So first of all, you have to solve the transpose. If I take the transpose of this, it will become 2 into, in transpose we change the rows into column, or you can say column into row. So this row will become the column, that is 1 minus 2, and this row will become the column, that is 3 4 minus 3. In the same way, you have to change the rows into column, and you have taken the transpose. Now you multiply 2 and 3 with the matrices. So when you multiply 2, it gives you 2 multiplied by 1, 2, 2 multiplied by 3, 6, minus 4 and 8. Minus, you have to multiply by 3, 3 into 0 gives you 0, 3 into this one, it will be minus 9, 3 into 7 gives you 21, 8, 3 with 24. Now you have to subtract these two matrices. So 2 minus 0, 6, plus 9. Why it is plus? This minus and this minus will become positive. So minus 4 and 21 plus 21, 8 minus, and it will be not minus, it is, oh, sorry, positive, it will be minus 8 minus 24. So if you simplify this matrix, it will be 2 minus 25, 9 plus 6, 15, then it will be minus 16. So this is the result of question 6 part number 2, in which we have to find out 2 into A transpose minus 3B transpose. I hope so it is clear to you. If still you have any difficulty, you may contact with me. Now we are going to solve question number 7, and this is very important question. So in this, the equation is given in the shape of matrices, and we have to find the value of A and find the value of B. So first of all, we will multiply 2 with this matrix and then 3 with this matrix, and then we will take out the equation from the matrices, because this is given in the shape of equation. So let me write the question first, that is 2 4 minus 3A. Question number 7 we are going to solve. Question number 7. 2 into it is 2 4 minus 3a, 2 4 minus 3a plus 3 into this matrix, and it is 1b8 minus 4. 1b8 minus 4, which is equal to another matrix which is given as well, that is 7 10 18 1. The entries are 7 10 18 1, and we have to find A and B. So first of all, multiply this 2 with this matrix and this 3 with this. If I multiply this 2, I will get 2 into 2 4, 8 minus 6 and 2a. I have multiplied this 2 with all the entries. Plus, now multiply 3 with all the entries of this matrix, you will get 3, 3b, 8 is 24, and 3 with 4 minus 12, which is equivalent to another matrix, that is 7, 10, 18 and 1. So now we have to add these two matrices. So if you add these two matrices, it will be 4 plus 3, 8 plus 3b, and now I hope so we have done so much addition of the matrices, you are clear that how we have to add the entries. 2a minus 12, which is equivalent to this matrix, that is 7 10 18 1. So as this is given in the shape of equation, so we will extract two equations from this. If you see, we will equate this 8 plus 3b with this 10. This 8 plus 3b is equal to 10, because both of these entries are having the same location. It is in the location of first row and second column. This is in the same location, first row, second column. So we can equate, or you can say we can make these two values equal to each other. And in the same way, 2a minus 12 is going to be equal to this 1. So we got two equation. I name it as 1, name it as 2. So from equation 1, that is 8 plus 3b is equal to 10. If I shift this 8 on the right hand side, it will be 10 minus 8, because here it is positive. When we change the side, it will change the sign as well. So here it was positive, when I change the side, its sign is negative. So 3b is equal to 10 minus 8 gives you 2. So b is 3 is multiplying with the 3, it will be shifted to another side in the denominator. It will be 2 by 3. 2 by 3. This is the value of b. And in the same way, you have to find out the value of a, that is 2a minus 12 equal to 1. 2a minus 12 is equal to 1. Shift this 12 on the other side, it will become 2a equal to 1 plus 12. And 1 plus 12 gives you 13, and it is equal to 2a. 2 is multiplying here. When we do cross multiplication on the other side, it will be this one. So we have find out the values of a and b. A is 13 by 2, b is 2 by 3. So I hope so this question is clear to you, and it is very important question. So now we are going to moving towards the last question, question 8, and it is similar to the question number 5. In this, we have to verify these equations which are given. So first two are very simple and straightforward, and they are of same nature. And such questions we have solved in the previous questions as well. So I'm going to solve one part from this, or I explained it to you here verbally, that you have to add the two matrices first of all, A and B. Whatever the result you will get, you will take the transpose, and in transpose you change the rows into column. And then on the right hand side, first of all you have to take the transpose of A, transpose of B, then you have to add the matrices. So I'm going to solve first part, and in the same way you can solve the second part. In second part, instead of adding the matrices, you have to subtract the matrix. So question number 8, and this is the last question of exercise 1.3. So let me write the matrices A and B first of all. 1 2 0 1. Question number 8, A is 1 2 0 1. B matrix is also given, and it is, I think, 1 1 and 2 0. So I'm going to solve first part, in which you have to find A plus B, the transpose, is equal to A transpose plus B transpose. So first of all, I am going to solve left hand side. In left hand side, first of all you will add the matrix A with matrix B plus 1 1 2 0. Whatever the result you will get, you will take the transpose of. If I add these values, 1 plus 1, 2 plus 1, 0 plus 2, 1 plus 0, this one is adding with this one, this 2 is with this 0 with this, and this is with this, with the same positions where they are present, and then we will take its transpose. So 2 into 0 plus 2, 2, 2 plus 1, 3, 1 plus 0, 1. Now we will take its transpose. If I take its transpose, it will be now change the rows into column 2, 3, and this row into column, it will be 2, 1. So we have find out the left hand side. Now we are going to solve right hand side, that is A transpose plus B transpose. So first of all, you have to take the transpose of A matrix. A matrix is given 1 2 0 1. Its transpose. Then second matrix is given. You have to take the transpose of second matrix B. Then you have to add. So if I take the transpose of these two matrices, it will be 1 2 0 1. I have changed the rows, this row into column, this row into second column, then plus this row is going to change into column because we have to take the transpose. Now add these two matrices. So it will become 1 plus 1, 0 plus 2, 2 plus 1, and 1 plus 0. So the result will be 2, 2, 3, 1. So see, either they are same or not. Here 2, 2, 3, 1, 2, 2, 3, 1. So both sides are equal. Left hand side is equal to right hand side. Hence verified. So in the same way, you have to solve the part 2 of question number 8. So now we are going to solve part number 3, that is A plus A transpose is symmetric and skew symmetric. So this is a new concept, that either the matrix is symmetric or skew symmetric. So first of all, let me explain the concept of symmetric. Symmetric. So remember, for example, if we have a matrix A that is 2, 2, and 2, 1. This is a matrix. If I take the transpose of this matrix, it will be A transpose, change the rows, 2, 2, this row is changed into this column, and change this 2 into 1. So there is no difference. If we take the transpose of a matrix and it is equal to the original one, so it is known as symmetric. If we get A is equal to A transpose, it will be symmetric. So this is that if we have A plus A transpose and then we so take the transpose of this both A plus A transpose, then if it is same, it will be symmetric. So I'm going to solve the third part first. So question number 8, part number 3, A plus A transpose. Let me again repeat the concept of symmetric. If one matrix is given, that is, for example, A is this one, and we take the transpose of that matrix, and the transpose of matrix is equal to the original of the entries of the matrix, it is symmetric. So first of all, we are going to solve this one. A matrix is given, that is, I think, 1 2 0 1. Let me check the values again. It is, yes, 1 2 0 1 plus A 1 2 0 1, A transpose of A. So first of all, take transpose of this, then you have to add 1 0 2 1 plus 1 2 0 1. Now if you add these two matrices, you will get 1 plus 1, 2 plus 0, 0 plus 2, and 1 plus 1, which is equal to 2, 2, 2, and 2. This is the value of this part, A plus A transpose. This is one value. Now we have to check either it is symmetric or not. To check that either it is symmetric or not, we have to take the transpose of this value, A plus A transpose of transpose. So first of all, you have to find this, and we have evaluated the value of this, that is 2, 2, and 2. Now take the transpose of this. If you take the transpose, it will make no effect. It will be the same one. No difference will be there, so it is symmetric. So you will say A plus A transpose is equal to A plus A transpose of transpose. So hence it is also verified. In part number 5, you have to first of all solve the matrix B plus B transpose. First of all, take the transpose. Whatever the result will be, add that with this B and you will get this value. Then take the transpose of that result. If it is same with this one, it will be symmetric. So now we are going to solve skew-symmetric. So here I am going to solve part number 6, that is B minus B, B minus B transpose. Question number 8, part number 6, that is B minus B transpose is skew symmetric. So always remember the concept of skew symmetric is that if you solve a matrix B, for example, you have a matrix B that is uh, we take the example of book that is given here, skew symmetric. A matrix is given here 0 2 3, and this is the matrix which is given. If you take the transpose and the values are not same, but if you take the minus value as common from there and then it is same, it will be your skew symmetric. Let me write this matrix here 0 2 3. transpose 0, 2, 3, minus 2, minus 3, 0, 1, minus 1, 0, 0, 1, minus 1, 0. If I take its transpose, it will be 0, 2, 3, minus 2, 0, 1, minus 3, minus 1, 0. I have changed the rows into column. And in previous part, we were discussing about symmetric, in which if we take the transpose of a matrix and the transpose is same as the original matrix was, it is known as symmetric. But this time it is not the same one. So to make it similar to the previous matrix, we will take minus common from here, or you can say you will multiply it with minus. So it will be minus A transpose is equal to minus 0, change the signs, minus 2, minus 3, 2, 0, minus 1, 3, 1, 0. Now it is same. And what we have done, either you can say we have taken the minus as common, or you have multiplied it with the minus sign. So in skew symmetric, if you have a matrix and you take its transpose and negative sign is also with it, it is known as skew symmetric. So now we are going to solve this B minus B transpose. So first of all, in this B minus B transpose, we will write the B matrix, and B matrix is given that is given here 1 1 2 0, 1 1 2 0, minus 1 1 2 0 and its transpose of B. So if we solve this, first of all we have to take the transpose. It will be 1 1 2 0 minus this. So now you have to subtract. So this one is going to subtract from this one. It will be 1 minus 1. This one with this, it will be 1 minus 2. This 2 with this one, 2 minus 1, 0 with this 0, it will be 0. So if you get the answer of this, simplify this. 1 minus 1 give you 0, 2 minus 1 give you 1, 1 minus 2 gives you minus 1, and it will be 0. So if you see, this is not the answer. This is just the value of B minus B transpose. Now you have to take the transpose of B minus B transpose. Transpose of B minus B transpose. So the value of B minus B transpose is this one. Means you have to take the transpose of this. If you take the transpose of this, it will be 0 minus 1 1 0, and it is not similar to this one. It is not similar to this one. See, this is 0 1 minus 1 0, and it is 0 minus 1 1 0. So what you have to do, you have to take the minus common or multiply it with. So you will change the signs. It will become now minus B, this term, because this is equal to this one. We have taken the transpose, minus is here, so they are now same. So it is known as skew symmetric. So I hope so you are clear about this exercise, and we have completed the exercise 1.3. And if you face any difficulty while solving the question or any part of this exercise, you may contact with me. And if you like this video, then do not forget to hit the like button. Thank you.